Question 1. What is a primary security benefit of using AWS Secrets Manager for database credentials instead of hard-coding them in application code? Option A. It allows database credentials to be retrieved by applications without any IAM permissions. Option B. It enables automatic rotation of credentials, reducing the risk of compromised or stale secrets. Option C. It stores secrets in plain text, making them easily accessible for debugging. Option D. It eliminates the need for any encryption for sensitive data. The correct answer is, quote, it enables automatic rotation of credentials, reducing the risk of compromised or stale secrets. Here's the explanation. AWS Secrets Manager's key feature is automatic secret rotation, especially for database credentials. This significantly reduces the security risk associated with long-lived or stale credentials by regularly changing them without manual intervention or application downtime. Question 2. An application retrieves a database password from AWS Secrets Manager. How is access to this secret controlled and audited? Option A. Access is controlled by the database's internal user management, and auditing is handled by database logs. Option B. Access is controlled through AWS IAM policies, and all secret management and retrieval events are logged to AWS CloudTrail. Option C. Access is open to any AWS service by default, and auditing is only available through custom CloudWatch metrics. Option D. Access is secured by a hard-coded API key within the application, and no auditing is performed by AWS services. The correct answer is, access is controlled through AWS IAM policies, and all secret management and retrieval events are logged to AWS CloudTrail. Here's the explanation. Access to secrets in Secrets Manager is strictly controlled using AWS IAM policies, allowing precise control over who can perform actions like get secret value. Furthermore, all interactions with Secrets Manager are logged to AWS CloudTrail, providing a comprehensive audit trail for compliance and security. Question 3. Which scenario is AWS Secrets Manager generally preferred over AWS Systems Manager Parameter Store, Secure String? Option A. Storing non-sensitive application configuration data that rarely changes. Option B. Storing database credentials that require automatic, scheduled rotation. Option C. Storing an API key that is static and does not need to be rotated. Option D. Storing environment variables for a Lambda function where cost optimization is the sole concern. The correct answer is storing database credentials that require automatic, scheduled rotation. Here's the explanation. Secrets Manager is specifically designed for secrets that require automatic rotation, such as database credentials, and offers built-in integration with AWS services for this purpose. While Parameter Store can store secrets, it lacks the native automatic rotation feature. Question 4. A solutions architect is designing a multi-environment application that needs to store configuration data and sensitive API keys. They require a solution that supports up to 50,000 parameters per account/region, allows for larger parameter sizes up to 8 kilobytes, and can trigger notifications when parameters change. Which AWS Systems Manager Parameter Store configuration best meets these requirements? Option A. Standard parameters, as they are free and offer sufficient capacity. Option B. Standard parameters, enabling parameter policies for notifications. Option C. Advanced parameters, which support higher quotas, larger sizes, and parameter policies. Option D. Advanced parameters, as they are free for up to 100,000 parameters and support 8 kilobytes values. The correct answer is advanced parameters, which support higher quotas, larger sizes, and parameter policies. Here's the explanation. Advanced parameters offer a higher quota, up to 100,000 parameters, larger size, up to 8 kilobytes, and support parameter policies like notifications, which are not available with standard parameters. While advanced parameters incur a cost, they meet the specified requirements for scale and features. Standard parameters are limited to 10,000 parameters and 4 kilobytes size and do not support policies. Question 5. An AWS Lambda function needs to retrieve a database password stored as a secure string parameter in AWS Systems Manager parameter store. The Lambda function's execution role has !SSM get parameter permissions. However, the function fails to retrieve the password. What is the most likely missing permission for the Lambda execution role? Option A, !SSM, describe parameters, Option B, KMS encrypt, on the KMS key used for the secure string. Option C, KMS decrypt, on the KMS key used for the secure string. Option D, S3, get object on an S3 bucket for parameter storage. The correct answer is KMS decrypt on the KMS key used for the secure string. Here's the explanation. Secure string parameters are encrypted using AWS KMS. To retrieve and decrypt a secure string parameter, the IAM entity, in this case the Lambda function's execution role, must have KMS decrypt permissions on the specific KMS key that was used to encrypt the parameter. Without this permission, parameter store cannot decrypt the value for the requester. Question 6. Which of the following is a primary benefit of using AWS Systems Manager parameter store for application configurations and secrets, compared to hard-coding values or using environment variables? Option A, it automatically rotates secrets like database credentials. Option B, it eliminates the need for IAM roles and policies for access control. Option C, it centralizes, versions, and secures configuration data and secrets, allowing dynamic updates without code deployments. Option D, it stores configuration data in plain text only, simplifying debugging. The correct answer is, it centralizes, versions, and secures configuration data and secrets, allowing dynamic updates without code deployments. Here's the explanation. Parameter store's primary goal is to provide secure, hierarchical, and version-controlled storage for configuration data and secrets. This allows applications to dynamically retrieve values at runtime, enabling updates without code redeployments, and enhancing security, especially with secure string. Automatic secret rotation is a feature of AWS Secrets Manager, not Parameter Store. Parameter Store relies heavily on IAM for access control, and it supports encrypted secure string values, not just plain text. Question 7. According to the shared responsibility model, which of the following is primarily the responsibility of the cloud provider? Option A, configuring network access control lists, NACLs, for customer subnets. Option B, encrypting customer data stored in a managed database service. Option C, patching the underlying hypervisor and physical server hardware. Option D, managing identity and access management, IAM, policies for customer users. The correct answer is patching the underlying hypervisor and physical server hardware. Here's the explanation. Patching the underlying hypervisor and physical server hardware falls under security of the cloud, which is the cloud provider's responsibility. Customer responsibilities. Security in the cloud include configuring NACLs, managing IAM policies, and encrypting their data, though the provider offers services to facilitate this. Question 8. A company deploys a custom application on an Amazon EC2 instance, IaaS. Which of the following security tasks is explicitly the customer's responsibility in this scenario? Option A, ensuring the physical security of the data center where the EC2 instance resides. Option B, patching the underlying virtualization software hypervisor that hosts the EC2 instance. Option C. Applying security patches and updates to the guest operating system installed on the EC2 instance. Option D. Maintaining the global network infrastructure that connects AWS regions. The correct answer is applying security patches and updates to the guest operating system installed on the EC2 instance. Here's the explanation. In an infrastructure as a service (IaaS) model like EC2, the customer is responsible for security in the cloud, which includes managing, patching, and securing the guest operating system and any applications installed on it. The other options are security of the cloud, responsibilities belonging to the cloud provider. Question 9. A small business utilizes a software as a service, say SaaS productivity suite, for email and document management, while the cloud provider manages most aspects of security. Which of the following remains a key security responsibility for the customer? Option A. Securing the application code of the productivity suite. Option B. Patching the operating systems of the servers running the SaaS application. Option C. Managing user accounts, enforcing strong password policies, and enabling multi-factor authentication, MFA. Option D. Protecting the physical data centers where the SaaS application resides. The correct answer is managing user accounts, enforcing strong password policies, and enabling multi-factor authentication, MFA. Here's the explanation. Even in a SaaS model, where the provider manages the application, operating system, and infrastructure, the customer retains responsibility for security in the cloud, aspects like managing user identities, access rights, and authentication mechanisms, e.g. strong passwords, MFA, within the application. Thanks for watching. Please subscribe to my channel